Hi everyone, welcome to goclasses. In this lecture, we will study the minimal cover of functional dependencies. We have already seen what is functional dependency, the definition of functional dependency, the concept of functional dependency we have seen. Now in this lecture, we will study what is minimal cover of functional dependencies. So you can see minimal cover of FDs. Let me tell you that it is also called minimal cover. You can also call it canonical cover. You can also call it irreducible FD set. Okay, irreducible set of functional dependency. So these three things are same. Remember, minimal cover, canonical cover, irreducible set of FDs. All these three things, they are same. Okay. Now let's start this. So first, let me tell you what the idea behind this minimal cover. What the idea? Let me tell you. We have already seen closure of functional dependency set, right? If you have a set of functional dependency, let's assume you have this set F of functional dependency. So you have a set of functional dependencies, and what is closure of this F? What is closure of F? So remember, if you have this set of functional dependency, let's assume this is the set of functional dependency that you have. This is F. Okay, what is this F? This is your set of functional dependency. You already know there are some functional dependencies in this. So this is your set of functional dependency. Now, what you can do? You can find closure of F. What is closure of F? From this F, you can find closure of F. So closure of F means basically you are expanding F, right? Yes or no? Closure means expanding F, right? Yes or no? Can I say that this set of functional dependency that you have, this F, this is set of functional dependency. There are some functional dependencies here. Now, what you can do? You can expand this, right? Yes or no? You can expand this and you can get this closure, this functional dependency closure you can get. So this is your FD closure. Is this clear? So remember what you can do? Set of functional dependency that you have, this is your set of functional dependency. You can expand and you can get this F plus. This means closure of F, right? Yes or no? What this means? This means closure of F. Okay, so this is what you can get. In this closure of F, you have many functional dependencies. Agree with me? So basically you are expanding. What you are doing? You are expanding. In this there will be many functional dependencies. Okay, yes or no? What will be the F closure? What is the definition of F closure? Tell me. F closure is all those FDs which you can derive from F. Yes or no? So remember, this G is a FD. This G is a FD. And you can derive this G from F. Okay, from F, you can derive this G. Okay, is this clear? So remember, set of all FDs which you can derive from F, those FDs you can put in a set, and that will be your closure of F. So very simple point. So remember, set of all FDs which you can derive from F, that is your closure of F. This we have already seen. This concept we have already seen. I told you that if you have a set of functional dependency, then this F closure, this will contain a lot of dependencies. Yes or no? Many FDs will be there here. Okay, yes or no? Okay, so it will contain a lot of FDs. It will contain all the trivial FDs. It will also contain those non-trivial FDs which you can derive from F. So basically, the collection of all the trivial FDs, also the collection of those non-trivial FDs which you can derive from F, this complete collection is your closure of F. Okay, so this is your F closure. So in this F closure, what we are doing? We are expanding. Okay, yes or no? We are expanding. Now remember one thing, that F closure and F, they are also equivalent, right? Yes or no? F is equivalent to F closure. They are equivalent. What it means? What this equivalent means? What this equivalent means? Tell me what this means, that they are equivalent. F and F closure, they are equivalent. What that means? That means that F covers F plus, F covers F plus, also F plus covers F. This is the definition of equivalence, correct? Okay, so very simple point, that F and F plus, they are equivalent. This set of functional dependency, this is equivalent to its closure. Very simple point. Yes or no? Also closure is unique. Also closure is unique, right? Also for any F, for any set of functional dependency, for any FD set F, if I give you any FD set F, then this F plus will be unique, correct? Yes or no? Agree? This F plus, this will be unique because this is set of all functional dependencies which you can derive from F. Is this clear? Very simple point. So this F plus, this will be unique. Okay, whatever FD set I give you, then this F plus, this will be unique. So very simple. So this is the idea, that if you have a set of functional dependency, you can expand and you can get a closure of F. Now, what is the another direction? What is another direction? Instead of expanding, what we can do? We can reduce, we can shrink, yes or no? Instead of expanding. So if you have this set of functional dependency, this is your set of functional dependency. This is the set of functional dependency that you have. Okay, here you have many functional dependencies you have. Now you can see if this is your set of functional dependency, then instead of expanding, what we can do? We can shrink, yes or no? We can shrink or we can reduce. Okay, I can say that we can reduce or I can shrink. This F I can shrink. Agree? Please tell me, is this clear? So you can see what we can do. This set of functional dependency, can we shrink? Can we reduce? Okay, can we reduce? Can we reduce? Can we reduce? So this set of functional dependency, this will be called FM. That means minimal cover. FM, that means minimal cover of F. Is this clear? So very simple point. This set of functional dependency you have, what you can do, either you can expand. Okay, if you expand, you will get closure of F. What you can do, you can expand and you will get closure of F. This closure of F will contain all the FDs which you can derive from F. Very simple. Now, the another direction, instead of expanding, what we can do, we can shrink, we can reduce. Okay, so this set of functional dependency we can reduce. Then we will get a set of functional dependency. Okay, this we will call it minimal cover. Very simple point. Okay, remember again that this minimal cover, this will be equivalent to F. Okay, of course they must be equivalent. Yes or no? They must be equivalent. So remember this minimal cover, this also will be equivalent to F. But this is basically, this is called minimal cover of F. This is called minimal cover of F. Okay, you can also call it canonical cover. You can also call it irreducible set of FDs. Okay, so remember, either you can call it minimal cover, or you can call it canonical cover, or you can call it canonical cover of F, or you can call it irreducible set of FDs. Irreducible set for F. Okay, I can say this is your irreducible set of FDs. Okay, which is equivalent to F, equivalent to F, equivalent to F. So very simple. So all these things are same. Remember, minimal cover, canonical cover, irreducible set. All these things are same. So this is the point that you have set of functional dependency. You can reduce this. You can reduce this. Okay, and you can get minimal cover. Very simple. Remember, minimal cover is also equivalent to F. Of course, they must be equivalent. Okay, they must be equivalent. But the point is, this minimal cover is not unique. This minimal cover, this need not be unique. We will see. I will give you the example. Okay, we will see this. But anyway, the point is very simple, that this minimal cover, this FM, this is also equivalent to F. They are also equivalent. What that means? Tell me what that means. What that means? That means this FM, this minimal cover, it will cover F, and this F will cover FM. Yes or no? Is this clear? Very simple. Also remember, this FM, this minimal cover need not be unique. This need not be unique. You can have many minimal covers you can have. Okay, so this need not be unique. Now what this means, this minimal cover, what this means, what the definition of minimal cover, this FM, this minimal cover, what this FM, we call it minimal cover of F. Minimal cover of F. Now what do you think, what this means, this minimal cover? So remember, minimal means you cannot reduce further. Yes or no? You cannot reduce further. Minimal cover, that means irreducible. This simply means irreducible set. Okay, this means irreducible set of FD. This is the point. Okay, means you cannot reduce further. This minimal cover you cannot reduce further. Okay, you cannot reduce further means from this minimal cover you cannot delete any attribute, any FD. Okay, minimal cover simply means you cannot reduce further. That is the reason this is minimal. Yes or no? That is the reason this is minimal, because you cannot reduce further. You cannot delete any attribute. You cannot delete any FD. This is already minimal. So remember, what is minimal cover? What the definition of minimal cover? Let me tell you the definition of minimal cover. So if I give you a set of functional dependency, for a given set of functional dependency F, what is a minimal cover? Minimal cover is basically irreducible set of FDs. Irreducible means you cannot reduce further. What it means? It means that you cannot remove any attribute, any FD. If you remove any attribute or any FD from this minimal cover, then what will happen? Tell me. Tell me. From this minimal cover, if you remove any attribute or any FD, if you remove, then what will happen? Then they will not be equivalent. Yes or no? Then they will no longer be equivalent. Okay, if you remove any FD or any attribute, notice, if you remove any FD or any attribute from FM, then they will no longer be equivalent. Is this clear? Very simple. Did you understand this? What is the definition of minimal cover? So remember, you have a given set of FDs, you have a given set of functional dependencies. Okay, let's call it F. This is your given set of functional dependencies. Then what is minimal cover? What is minimal cover? Minimal cover of F. This minimal cover of F. What is minimal cover of F? We denote it by, either you can denote by FM or you can denote by FC. What that means? What this C means? Please tell me. What this C means? This C means canonical. Yes or no? Or you can denote by FIR. That means irreducible. Okay, is this clear? So remember, minimal cover of F. What is that? Minimal cover of F. Basically, this minimal cover of F, FM. What is this? This is equivalent to F. This minimal cover of F. This has these two properties. There are two properties. There are two properties. The first property is that this minimal cover is equivalent to F. And the second property, what is that? That it is irreducible. Yes or no? It is irreducible. Okay, it is irreducible. This FM is irreducible. Okay, is this clear? Please tell me. Okay, so FM is irreducible. Irreducible. This FM is irreducible. Okay, now what this irreducible means? So remember the definition of minimal cover. What is that? The minimal cover is equivalent to F. This is the first property. And the second property, what is that? If you remove any attribute or any FD from this minimal cover, then it will not be equivalent to F. Yes or no? Is this clear? If we remove any attribute, okay, if we remove any attribute or any FD from FM, then what will happen? Then they will not be equivalent. Yes or no? Then they will not be equivalent. Is this clear? Please tell me. Then the result will not be equivalent to F. Is this clear? Then the result will not be equivalent to F. So this is the idea. Okay, very simple. Is this clear to everyone? So this is the definition of minimal cover. If anyone asks you, what is the definition of minimal cover? What is that? For a given set of functional dependency, minimal cover is irreducible set of FDs. Means you cannot reduce further. What it means? It means that if you remove any attribute or any FD, then the result will no longer be equivalent to F. Okay, this is the definition of minimal cover. The name itself is telling you minimal. Minimal means you cannot remove anything. Okay, if you remove something, then the result will not be equivalent to F. The result will not be equivalent to F. Okay, so you can see this word is better. Yes or no? Minimal cover, irreducible set of FD. Which word is giving you more intuition? Which word is giving you more idea about the definition of minimal cover? This word, right? Irreducible set of FDs means you cannot reduce further. You cannot reduce further. Okay, if you delete any attribute or any FD, then the result will no longer be equivalent to F. So this is the idea. I hope you understood the definition. Okay, very simple point. Okay, so the same thing is given here. Whatever I told you, that is also given here. The definition of minimal cover is given here. Okay, this we have already seen. Now let's move on. For example, consider this set of FDs. This set of FDs that is given to you. Okay, this is your set of FDs. Let's call it F. So this is your FD set F. Okay, now in this FD set, can I remove some FD? Can I remove some FD? Is this minimal? This FD set is given to you. From this FD set, can I remove some FD such that the result is equivalent to F? Such that the result is equivalent to F. Look at this FD set. Is this minimal? Is it minimal? Tell me, is it minimal? This is my question. This FD set is given to you. Now I'm asking, is this minimal cover of F? Is this minimal cover of F? The answer is no. The answer is no, because what you can do, notice one thing, what you can do, you can delete E determining S. Okay, see, notice this, what I can do, just focus here, what I can do, I can delete this E determining S. Okay, I can delete this, I can delete this, still the result will be same equivalent to F. Yes or no? See what I'm saying, from this I can delete this and I can still get equivalent to F. The result will still be equivalent to F. So this is what I'm saying. Okay, so we can delete, okay, we can delete this, we can delete this, we can delete and still get FD set equivalent to F. FD set equivalent to F. Equivalent to F. Okay, yes or no? Equivalent to F. So very simple point. So this is the idea. So remember, very simple point I'm telling you, that this FD set F, this is actually equivalent to E determining G and G determining S. Can you notice they cover each other? Can you notice they cover each other? Can you notice they cover each other? Okay, you can notice here, can I derive E determining S? Here, can I derive E determining S? Yes, transitively. E determining G, G determining S. So transitively E determines S. So very simple. Can you notice this will cover this? Okay, and this will cover this. So they are equivalent. So they are equivalent. Yes or no? And tell me one more thing. Can I remove something from this? Is this minimal? Is it minimal? Tell me. See what I'm saying. This set is equivalent to this set. These two sets are equivalent. These two sets, they are actually equivalent. Can I delete something from this? For example, if I delete this, will it be equivalent to? Means what I'm doing, I am deleting this. The result, is it equivalent? Are they equivalent? These two, are they equivalent? No, they are not equivalent. No, they are not equivalent, because here you can notice, here G does not derive S. Okay, G does not determine S. So you can notice this is not equivalent. Okay, this is not equivalent, right? So what I can say, I can simply say that this is your minimal cover. Is this clear? This is your minimal cover of F. Okay, you cannot delete anything. If you delete something, if you delete this, then the result will no longer be equivalent to F. Okay, very simple. So this is your minimal cover of F. I hope you understood the definition. Minimal cover means irreducible. You cannot reduce further. Okay, this minimal cover, this simply means irreducible. You cannot reduce further. Irreducible set of FD. So this is the idea. Now let's move on now. Now let's see a subtopic, a small topic we will see, that is extraneous attributes on LHS of FD. If I give you some functional dependency, then on the LHS, what are extraneous attributes? Extraneous attributes means extra attribute. The name itself is telling you extra attribute. So on the LHS of FD, what is extraneous attribute? Let me tell you the definition. Let's assume you have a set of FDs. Let's assume you have a set of FDs and this is your set of FDs F. Okay, so some set of FDs you have. Now in this, let's assume there is a FD that is alpha determining beta. Okay, let's assume there is a FD that is alpha determining beta, or let me call it XA determine Y. Okay, so let's assume this FD you have. Of course, you can have more FDs, but this is one of the FDs that is what you have. Now, when can I say this A is extra? So let's assume that this A, remember this FD you have, this particular FD you have, that is XA determining Y, this particular FD you have. Now, remember here, this A is single attribute. Please notice this A, this is a single attribute. This is not set of attribute. This is a single attribute. This X comma Y can be anything. They can be anything. They are set of attributes. They can be anything. Okay, they can be anything. Is this clear? X comma Y, they can be anything. But this A, this is a single attribute. Okay, this is single attribute. Now, when can I say that this A is extra? When can I say this A is extra? Remember, our topic is extraneous attributes on LHS of FD. Okay, if I give you some FD, then on the LHS, which attributes are extra? We want to check it. We want to check which attribute is extra. This is what I want to check. Is this clear? So what I will do, basically I will take care of individual attributes. I will check each attribute. Agree with me? I want to find out on the LHS of FD which attribute is extra. Okay, yes or no, which attribute is extra. So I will check each attribute on the LHS. Okay, anyway, so you can see this is your set of functional dependency. These are the set of functional dependency. Let's assume this A is single attribute and this XY, these are set of attributes. Okay, now in this situation, in this FD, when can I say A is extra? When can I say A is extra? Here. So remember here, when can I say A is extra? In this, I can say A is extra. A is extraneous on LHS. A is extraneous on LHS. If A is extraneous on LHS, if this X can derive Y. Okay, notice. This A is extra on LHS if X plus contains Y. You find X plus and that X plus contains Y. Is this clear? So remember, this A is extraneous. This A is extraneous on LHS if X can derive Y. Okay, in F. In this F. Remember, in this F. In this F. Okay, so very simple point. Is this understood? X can determine Y in this F. So very simple point. This is what I'm saying, that A is extra. When can I say this attribute is extra on LHS? This attribute is extra on LHS if you find X plus, okay, X plus contains Y. Okay, X plus contains Y. Is this clear? You find X plus and that contains Y. Okay, and this you need to do in F, that is given FD set. Okay, is this clear? Very simple. So please tell me, did you understand? So remember, this A will be extra if X can determine Y. This is quite intuitive. Please tell me, are you getting the intuition? When can I say this is extra? When can I say this is extra? If X can determine Y. If X can determine Y, then this is extra. Agree with me? Is this clear? Very simple point. Okay, so this will be extra if X plus contains Y. If X can determine Y, then this A will be extra. Please tell me, is this clear? Let me know. See, it's something like this. Okay, let's assume X is helping Y. Okay, let's assume they are helping Y. They are helping Y. Now, what this X can do? This X is saying that I can also help Y. Okay, let's assume that XA is helping Y, but you check and you find that X can also help Y. Then it simply means this A is extra. Yes or no? Is this clear? Please tell me. Okay, if this situation happens, then what I can say? Then I can say that A in this XA, basically this A is extra. Yes or no? I can simply say this A will be extra. If this happens, then what I will say? Then I will say this is extra. Please tell me, did you understand? Then I will say this is extra. We will call it extraneous. So this is your intuition. Please tell me, did you understand? Let me know. This definition, did you understand? Very simple. That this FD you take, okay, this A, this is a single attribute, this A is single attribute, X, Y, they can be anything. They can be single attribute, they can be set of attribute, okay, they can be anything. Now, this A is extra if X can determine Y. This A is extra if X plus contains Y. So this is the idea. Please tell me, did you understand the intuition? Did you understand the intuition? Let me know. This intuition, did you understand? Now, let's check this example. Consider this example. In this example, you tell me, okay, let's check. In this example, you tell me, can I say this B? Okay, let's check this B. Is this extra? Let's check this B and tell me. Okay, this is your set of FDs. Remember, this is your FD set F. This is your FD set F that is given to you. Now you tell me about this B. Is this B extra? Is this B extra? Is this B? Okay, is this B? You can see this is on LHS, right? Okay, is this B extra? This is my question. Is this extra? Let me know. This B, is it extra? Please tell me. Is this B extra? What you will do if you want to check this B is extra or not? What you will do? Please tell me. Is this B extra? What you will do if you want to check this B is extra or not? You want to check this B is extra or not? What you will do? You will find A plus in this entire F. Okay, in this entire F, please understand, in this entire F, you just find what is A plus. Okay, basically you check, can A determine C? Okay, basically, okay, you want to check this B is extra or not? This B, this is extra or not? So what you will do? You will check, can A determine C? can A determine C? Okay, so what you will do in this FD set, you will find what is A plus. So tell me what is A plus? A plus, if you find A can determine A can determine B, and AB can determine C. So can you notice that A can determine C? Can you notice that A can determine C? Yes or no? A can determine C. So I can say that A can determine C. Remember, A can determine C. So can I say B is extra? B is extra. The answer is yes. Okay, the answer is yes, because if you find A plus, that contains C. Because if you find A plus, that contains C. Is this understood? Please tell me. So remember, this B, this is extra. This is B is extra. So what we can do? Because this B is extra, so what we can do? Tell me. This B, this is extra. This is extraneous. So tell me what you can do. So you can remove it. Okay, you can remove it. Now you can easily check that this set, this is actually equivalent to this set. Can you check? Are they equivalent? Please tell me. Are they equivalent? Let me know. Okay, check it. Are they equivalent? These two sets, are they equivalent? For example, first you check this set of FD. Will it cover this set of FD? Let me know. Let me call it F and let me call it G. Now tell me, can I say F covers G? Can I say F covers G? Please tell me. Check it. Can I say F covers G? For example, is this covered by F? Is this covered by F? Yes, this is covered by F. Okay, in this F, if you find A plus, then you will get C. Yes or no? Okay, this is covered by F, because in this F, if you find A plus, you will get C. Similarly, is this covered by F? Yes, this is also covered by F. So F covers G. The answer is yes. Can I say G covers F? Can I say G covers F? Tell me. Can I say G covers F? In this G, tell me, is this G covering F? For example, is this covered? Yes, this is covered. This is covered. What about this? Is this covered? AB determining C. Is this covered? In G, you find what is AB plus. In this G, you find what is AB plus. In this G, you find what is AB plus. What that will be? If you find what is AB plus, that will be ABC. So can I say that, yes, this FD is also covered, this FD is also covered. So G covers F, yes. So I can say that F is equivalent to G. They are equivalent. Is this understood? Please tell me. Let me know. Is this understood? Okay, very simple. In the same question, let's assume this question is given to you. This FD set F is given to you. Now you tell me, in this same question, can I say this A is extra? What about this A? What about this A? Is this A extra? Is this A extra? What you will do? Just apply the intuition. You want to check, is this extra or not? This A is extra or not? So you will make sure that can B determine C. So in this FD set, what you will do? You will find out what is B plus. Tell me what is B plus. B plus is only B. B plus is only B. So I can say that B cannot determine C. Yes or no? So this A is not extra. Yes or no? Is this A extra? The answer is no. The answer is no. Why? Because what is the reason? Because you can see that B plus does not contain C. B plus does not contain C. Does not contain C. Okay, so this A is not extra. Okay, this A is not extra. Is this clear? Please tell me. Now let me tell you a very common mistake. A very, very, very common mistake I want to tell you. That is, what is the very common mistake? If I ask you, is this extra or not? Then what is a common mistake? Let me tell you. Basically, my question is this extra? Okay, you want to check. Check if it is extra. Check if this B is extra. Okay, then what is a common mistake? Let me tell you. What is a common mistake? The common mistake is this. Okay, I'm asking you to check if this B is extra. Okay, then what is a common mistake? This is a common mistake that first you remove this B. Some students, okay, what they can do, okay, by mistake, because this is a very common mistake. Okay, this can happen. So by mistake, what they can do, they can first remove it and then they will check, can A determine C? Okay, see what I'm saying. So if you want to check, then what is a mistake? The mistake is this. Let me tell you the mistake. Okay, this is a common mistake. It can happen. So you should take care. Okay, what is the mistake? Mistake is First you remove this B, then you check will A determine C. Okay, removing B, then checking, then checking, then checking, does A determine C? Okay, is this clear? So first you remove B, then if you check, okay, then if you check, notice first you remove B, then if you check A determines C, this is a mistake. This is a mistake. Is this clear? Please tell me, did you understand the mistake? The common mistake. What the common mistake? First removing, then checking. Okay, first removing, then checking. This is a mistake. Okay, so don't do this mistake. First removing B, then checking, does then checking A determines C or not. Okay, did you understand? Please tell me. Okay, is this clear? Because if you first remove C, then what will happen? See, first if you remove from this, first if you remove B, okay, let's assume first you remove B from here. First, if you, let's assume you remove B. Okay, let's assume this you have removed. What you have done? This B you have removed. Let's assume this you have removed here. Okay, now if you check, so in this example, actually it is working, right? Okay, it is actually working in this example. In this particular example, this is working, that first you remove, then you are checking. Okay, so but anyway, okay, here actually it is working, but it is a mistake. In this example it is working, but it is a mistake. Okay, anyway, see, in this example it is working, but this is a mistake, I want to tell you. Okay, anyway, did you understand the mistake? Some more example will come in future. Okay, we will take a lot of questions we will take. Okay, so everything will be clear. But tell me, did you understand the point? Did you understand that in this given FD set you have to find what is A plus? Okay, in this given FD set you have to find what is A plus. Is this clear? Please tell me. Okay, so anyway, let me tell you, in this example actually there is no problem, but in some other example it can happen. So let me tell you. Okay, see, some students are confused, so let me tell you a common mistake. First let me tell you the mistake, and then let me tell you the correct way. Okay, see, you have this FD set. Okay, you have this FD set. In this FD set you have some FDs. Now let's assume one of the FDs is XA determining Y. This is one of the FDs. Okay, now what you want to check? You want to check this A is extra or not. Okay, in FD, let's assume this is your FD, XA determining Y, and what you want to do? You want to check this A. This is a single attribute. Okay, this is a single attribute. Okay, you want to check this attribute is a extra or not. Okay, so what you want to check? You want to check this A is extra or not. Okay, this extraneous or not. So this is what you want to check. To check this A is extraneous or not. Okay, the mistake. What is the mistake? The mistake, let me tell you what the mistake. The mistake is first you remove this A, and okay, the mistake is this. First you remove this A. Basically you will remove this A, then in the result you will check X plus. Okay, so first remove A. Okay, then in the resulting FD you find X plus. Then in the resulting FD set you find X plus. Is this clear? So don't do this. This will be a mistake. I'm telling you, this will be a mistake. If you do this, this will be a mistake. Okay, now what the correct way? So let me tell you what the correct way. The correct way is this, that if you have this FD XA determining Y, okay, this is your FD, and you have FD set, and you have this FD set F. Okay, in this FD set F, okay, you have many FDs, and let's assume one of those FDs is your XA determining Y. Okay, so you have FDs, and one of those FDs is XA determining Y. Now, what I'm saying here, this A, is this extra or not? So what you will do? This A is extra or not? Extraneous or not? So for that, what is the method? Tell me what is the method? The method is in this f. Okay, in this f, you find x plus. Okay, so remember what you do. You find x plus in f. Is this clear? Let me know. In this f, you have to find x plus without removing anything. In this f, you find what is x plus. In this f, you find what is x plus. Okay, is this clear? So find x plus in f. Then, okay, then if x plus contains y, then what I will do? Then if x plus contains y, then what I will do? Then a is extraneous. Yes or no? Is this clear? Then a is extraneous. Please tell me, did you understand? So remember, in this given FD set, you have to find x plus. Okay, in this given FD set, okay, this is given. In this, you find what is x plus. Then you can easily see, okay, if x plus contains y, then what I can say? Then I can say that a is extraneous. Let me give you example. Okay, let me give you this example. Some students were asking, for example, it has come to my mind. It has come to my mind. So let me give you this example. Consider this relation in which you have 4 attributes, and consider this FD set F. Consider this FD set F, which has AB determining C. Okay, now, that's it. Okay, so here you tell me, is this B extra? I'm asking, is this B extra? I'm asking, is this B extra? Is this B extra? Is this B extraneous? Please tell me. Is this B extraneous? Let me know. The common sense will tell you that this is not extra, right? Yes or no? The common sense is telling you this is not extra. Do you agree with me? This is your FD set. This is your FD set. And the common sense is telling you that this is not extra. Okay. So you can see that this is not extra, right? Why this is not extra? See, in this F, you find what is A plus. I want to check it. This is what we are checking. We are checking this B is extra or not. Is extra or not. We are checking this B is extraneous or not. This is what we are checking, right? Yes or no? This is what we are checking. Okay, so if you are checking this B is extraneous or not, then in this F you find what is A plus. Find A plus. So tell me what will be A plus? Let me know. What will be A plus? A plus will be A. So A cannot determine C. Yes or no? So A cannot determine C. So what I can say? So this B is not extraneous. Yes or no? So this is not extra. This is actually very important. Yes or no? This B is actually important. This is not extra. This is actually important. Yes or no? Is this clear? But if I tell you to check it, and let's assume you delete it, and then you check A determines C or not. Yes or no? That is a mistake. Okay, this is you are checking. This is what you are checking. This is this B you are checking. Is this clear? Okay, this B you are checking, and let's assume that first to delete this B, then you find can A determine C. Is this clear? Okay, this is a mistake. What the mistake? The mistake is first to delete this B. First to delete this B. Okay, this is the mistake. This is the mistake that you first deleted B. That first you deleted B. Okay, then in this you are checking. Then in this you are checking A plus. Of course, A plus will be AC. Yes or no? Is this clear? Of course, A plus will be AC. Of course. Okay, so did you understand what I'm trying to tell you? Okay, is this clear? Please tell me. Did you understand the point? The point did you understand? Okay, so final conclusion. Let me give you the final conclusion. This is the final conclusion. This is the final conclusion that you have FD set. This FD set F is given to you. Okay. Now, in this FD set, this FD you have X, Y, Xi determining Y, where this A is a single attribute. Where this is a single attribute. Okay, and you want to check this A, this is extra or not. Okay, so remember this A is extra or not. So in this FD, look at this FD, XA determining Y. In this FD, this A is extra or not. I want to check this A. This A is extra if and only if this A is extraneous if and only if x plus contains y, x plus contains y, x plus contains y in what? In F, yes or no? In F, you have to find in F. So x plus contains y in F. Then you can say that this A is extra. Okay, then you can remove it. So this is the idea. Is this understood? Please tell me. Consider this example on your screen. Now let's find out all the extraneous attributes on LHS. Okay, let's assume your question is find extraneous attributes on LHS. This is the question. Find extraneous attributes on LHS. On LHS of FDs. Okay, so this FD set is given to you. You have to find extraneous attributes on LHS of FDs. You have to find on LHS of FDs. So please tell me, in this FD on LHS, can you have extra attribute? In this FD on LHS, can you have extraneous attribute? No, only single attribute is there. So nothing to check. Yes or no? Single attribute on LHS. Yes or no? Single attribute on LHS. Single attribute on LHS. So there is nothing to check. So there is nothing to check. Agree? So we have nothing to check here. Because only one attribute you have. Only one attribute you have. So of course there is nothing to check. Yes or no? You cannot, because only one attribute on the LHS, you only have one attribute. Okay, there is nothing to check. Agree with me? Okay, yes or no? What you will check with? What you will check with? Yes or no? When you have XA determining Y, what plus you are finding? Here, what plus you are finding? To check A. To check A is extra. To check A is extraneous. What closure you are finding? Tell me. To check A is extraneous, what closure you are finding? You are finding X closure. Yes or no? We find X closure. Agree? We find X closure. So you can easily see if you have only one attribute, X is phi, X is empty. There is no X. Can I say? Okay, so single attribute, so nothing to check. So there is nothing to check. Now you tell me, so where should we check? Single attribute, nothing to check, nothing to check, nothing to check. So in these three, there is nothing to check. So where should I check? In these three, there is nothing to check. Nothing to check on LHS. Nothing to check on LHS. On LHS, there is nothing to check. So in the last one, now you tell me, in the last one, you tell me, can I say P is extra? In the last one, you tell me, can I say P is extra? Please tell me. Here, can I say P is extra? In this one, can I say P is extra? This P is extra, why? This P is extra, why? So here you can notice in this last one, can I say P is extraneous? The answer is yes. Why? Because in this F, you find what is Q plus. In this F, you find Q plus. Okay. In this F, if you find Q plus, what that will be? That will be QR. That will be QR. So you can notice that, can I say that this Q determines R? Okay. This Q, this can determine R. Okay. Because this Q can determine R. Because this Q can determine R. So I can say this P, this is a extra. Is this clear? So this P is extra. Is this clear? Let me know. Okay. So because this P is extra, so I can remove it. I can remove it, right? Yes or no? So this is extraneous. Because this is extraneous, so I can remove it. Okay, extraneous. So we can remove. So we can remove it. Okay. So what you can do? You can just simply, you can remove it. This you can remove. Simple. Okay. This you can remove. Is this clear? Please tell me. Okay. Now you tell me, if this question is given to you again. Okay. Let's come back to this question again. Again, this question is given to you. Revisiting this question again. Revisit same question again. Okay. We are revisiting this same question again. Now, let's assume you check for Q. Is this extra? Instead of P, check Q is extra or not. This F is given to you. Revisit this F again. Okay, we are revisiting this F. This question we are revisiting. Now you tell me, if I check this Q is extra or not. This Q is extraneous or not? Please tell me. Can I say this Q is extraneous? The answer again is yes. Yes or no? Can I say this Q is extraneous? The answer again is yes. Why? What the reason? What is the reason? Because in this F, you will find what is P plus. What is P plus? P plus will be PQR. So you can see that in this F, this P is determining R. This P is determining R. Okay, yes or no? This P contains R. So I can say this Q is also extra. So I can remove this Q also. Yes or no? So because this Q is extra, so what I got, this Q is extra. So I can remove this Q. Okay, this is extraneous. So what I can do? So can remove. So what we can do? We can remove. Okay, so you can remove it. This Q, you can remove it. Now, can I say P is also extraneous? Q is also extraneous. Can I remove both of them? See, in this P is also extraneous. This P is also extraneous. This Q is also extraneous. Can I remove both of them? Think about it. This P is also extraneous. In this, if you check, in this, if you check, this P is also extra. This Q is also extra. So can I remove both of them? No, don't remove both of them because you are checking one at a time. You are checking one at a time. Yes or no? Don't remove both of them. You are checking one at a time. For example, in this example, if you check this, then you can remove this. Okay. For example, in this question, if you start by checking this, then you can remove this. But don't remove both of them. We always go one by one. Yes or no? We always go one by one. So don't remove both of them. This is given in this book. In this course, this is your course. This book, this is your course. Okay, in this book, you can see this is given that sometimes what can happen? Two things can be extra. Okay, if you check, two things can be extra. Both can be extra. But don't remove both of them. It is incorrect to delete both of them. Okay, if you delete both of them, that is wrong. Okay, what your algorithm will do? It will do one by one. Okay, one of them you can delete because you know this is extra. If you check, this is also extra. One of them you can delete. Is this clear? Please tell me. Please tell me. One of them you can delete. So tell me. So what I can do? I can delete this or I can delete this. One of them I can delete. What I can do? I can delete this or I can delete this. One of them I can delete. So I will get multiple minimal cover. That is the reason. Can I say you don't have unique minimal cover? Yes or no? Is this clear? Which of them you delete, depending on that, you can get different minimal covers. So can you notice minimal cover is not unique? Is this clear? Please tell me. Minimal cover is not unique. Okay. Please tell me. Is this understood? Let me know. Okay. Now let's move on. In this example, this is the set of FDs that is given to you. Find extraneous attributes on LHS of FDs. We have to find which attributes are extra on LHS of FDs. This is what we have to find. Okay, so let's start this question. Let me start this question by checking. What about this A? Check this A. Okay, check this A. This is what I'm asking. Check this A. Check this A. So what you will do? What you will do? In this entire F, you will find what is C plus. Yes or no? What you will do? In entire F, please understand, in entire F, you will find what is C plus. In entire F, you find what is C plus. You find what is C plus. So tell me what is C plus in the entire F. If you find C plus in the entire F, you have to find. So if you find C plus, what that will be? That will be only C, nothing else. Yes or no? Agree with me? Okay, in the entire F, you have to find. So please understand, in this entire F, you have to find what is C plus. What is C plus? So that will be C only. So can I say C does not derive G? Yes or no? So can you notice C does not derive G? Okay, so what I can say? So what I can say? So this A is not extra. Okay, so this A in this FD is not extra. Is not extra. Okay, so this is actually important, right? Can I say this A is actually important? Yes or no? This is not extra. You cannot delete it. This A is actually important. Okay, so very simple point. Now, in the same question, you tell me, what about this G? What about this G? Or maybe instead of this G, you tell me, what about this C? Which of them should I ask? For example, let's ask this C. Tell me, what about this C? Is this C extra? Check this C. Check this attribute C on the LHS. If you want to check this C, then what you will do? What you will do, tell me. In entire F, what you will find? In entire F, you are going to find what is AD plus. Yes or no? You are going to find what is AD plus in this entire F. Okay, in this entire F, you will find what is AD plus. So tell me, what is AD plus? AD plus will be AD. D can determine EG. D can determine EG. What else? Tell me. Is there anything else? Is there anything else? So can you notice? That's it. Yes or no? So here, can I say again? Again, what I can say? Again, you can notice that AD does not determine B. Yes or no? So again, this C is also not extra. So this C is not extra. Okay, this C is not extra. Please tell me, understood? Okay, this C that you are checking, this C is not extra. Is this clear? Let me know. Understood? So quite simple. Let's see another example. In the same question, let me check. Okay, in the same question, let me check this D. Is this extra? Let me check this D. Check this D. Please tell me. We are doing the practice of extraneous attribute. Remember, we are doing the practice of finding extraneous attribute. Check this D. So for this D, what you will do? In the entire F, in this entire F, you will find, okay, what you will find? You will find what is AC plus. So what is AC plus? AC will give you AC. That will give you G. Okay. CG will give you D. CG will give you D. Then this ACD will give you B. Yes or no? Notice, this ACD will give you B also. So you got B also. What else you will get? Tell me. ACGDB. This D will give you E also. Okay. So you got ABCD GE. ABCD GE. You got this. So you got everything, right? Yes or no? Is this clear? You got everything. So here you can easily see that AC can determine B. Okay, so what I can say? So this D is extra, right? Yes or no? So this D is actually extraneous on LHS. This D is actually extraneous. Okay, this D is actually extraneous. So you can remove it. Is this clear? This is actually extraneous. So remove. So can remove. So what I can do? I can remove. Okay, remember what we can do? We can remove it. So this D we can remove. We can just remove it. So this D, this will be gone. Okay, is this clear? Anyway, did you understand the concept? Please tell me. The concept, did you understand? Let me know. Did you understand the concept? That what is, how to find extraneous attribute on the LHS? Okay, so far we have seen how to find extraneous attribute on the LHS. Did you understand the concept? Please tell me. Now let's move on now. Okay, so this is what we have seen, how to find extraneous attribute on the LHS. This concept we have seen. Okay, so this also we have seen. Very simple. Now let's move on. Now let's see another subtopic, another small topic, that is removing a redundant FD. Okay, now we will focus on the entire FD. Yes or no? Now we will focus on entire FD, on entire FD. This is what we are going to focus. So removing redundant FD. Now, before removing this redundant FD, before we remove this, first what you do? First you make sure that RHS has single attribute. RHS of every FD that has single attribute. Why we are doing this? Please tell me. RHS of every FD has single attribute. We are doing this for simplicity. Okay, it will simplify the process. Okay, it will simplify the process. So what we will do? First, we will make sure that RHS of every FD has single attribute. Can we do this? Can we always do this? Is it possible that we can always get, basically we can always get on the RHS single attribute? Is it possible? Please tell me. Is it possible that I can always get only single attribute on RHS? Yes, we can split on RHS. Yes or no? Because we can split on RHS. Remember, this you already know, that split rule on RHS. Split rule on RHS. Split comma combine rule. You can split also, you can combine also. Okay, so this you already know. What is the split rule? I can say split / combine. You can combine also, you can split also. What that rule? That rule is something like this. If you have alpha determining AB, then this is equivalent to what you can do? You can do alpha determine A, alpha determine B. These two things are actually equivalent. Yes or no? These two things, they are actually equivalent. So you can combine also, you can split also. Okay, such that you have single attribute on RHS. Such that on single attribute, you have single attribute on RHS. Okay, this is your single attribute. This is a single attribute. Also, this is a single attribute. Okay, is this clear? So this is what you can do. So remember, what we are doing, our next subtopic, what is that? That is removing entire FD. Entire FD we will remove. Redundant FD we will remove. But before that, you make sure that on RHS, you have single attribute. Make sure that RHS of every FD that has single attribute. Okay, so this is what you can do. You can split on RHS. Okay, now what is the rule? Now let me tell you the very simple rule. So once you have done this, let's assume you have FD set. This FD set F you have. Okay, this is your FD set F. Such that on RHS you have single attribute. Okay, is this clear? Such that on RHS you have single attribute, something like this. So let's assume these are the FDs. This is your alpha, something like this. Okay, I hope you are understanding. So remember, these are single attributes. So this is what we have done. Now, let's check, is this redundant? This FD, is this redundant? So what we will do? If you want to check, let's assume you want to check this FD is redundant or not. This FD. Okay. So to check this FD is redundant or not, what you will do? To check this FD. Okay, this FD, gamma determining B, this FD is redundant or not? Is this FD redundant? The entire FD redundant or not? What we will do? First we will remove this, and then we will check in the result, can you get this FD? Okay, so remember this point. What we will do? First we will remove this, and then we will find in the remaining, can gamma determine B? Okay, so remember what we will do? First remove this. First remove this gamma determining B, okay, from F. Then what you do? Then you find this gamma plus. Okay, then find gamma plus. Then what you do? Then you find gamma plus. Gamma plus and C, does it contain B? And C, does it contain B? Does it contain B? Is this clear? Okay, so first you remove this FD. First you just remove this FD. Then you check the remaining FDs. From the remaining FDs, can you determine, can this gamma determine B? Okay, can this gamma determine B? If this can happen, just think about it. Please tell me. I remove this. Okay, let's assume this is gone. In the remaining, gamma plus contains B, means gamma can determine B. In the remaining, gamma can determine B. Then can I say this is redundant? See, these remaining people, if in these remaining people, if gamma can determine B, then this is redundant. Yes or no? Is this clear? Please tell me. So this is the definition. You can see, just look at the definition. If you have this FD you have in F, you want to check is this redundant or not, then what you will do? First you remove this from F. From F you remove this, and then you check. Is this still equivalent to F? Means first you remove this FD from F, then you check, can X determine A? Okay, first you remove, then you check, can X determine A? Is this understood? Please tell me. Is this understood? So remember, this is the simple point. This FD set you have. Okay, this FD set, X determining A, and there are more FDs. Remember, this is a single attribute. Remember, this is a single attribute. On RHS, you have single attribute. Now you want to check, is this FD redundant or not? This FD is redundant. When can I say? this FD is redundant if and only if, when can I say? If and only if in F minus this FD, okay, this FD you remove, this FD you remove, okay, in F minus this, okay, in this what you do, in this, please understand, in this X plus contains A. Is this understood? Let me know. So first you remove this, and in the remaining here, in the remaining you find X plus. If X plus contains A, then tell me what will happen. Here, if X can determine A, then can I say this is redundant? Yes or no? Here, if X can determine A, then can I say this is redundant? Yes, this is redundant. Okay, simple, very simple. Okay, so first you remove this, and in the remaining you find X plus. Can X determine A? Can still X determine A? So this is the idea. Now let's see this question again. Find redundant FDs. So first what you will make sure to check whether FD is redundant or not. First what you will do, please tell me. First you will make sure that on RHS you have single attributes. Do we have single attribute on RHS? Do we have single attribute on RHS? Tell me. Yes. Okay, so you can see we have single attributes on RHS. That is already done. We have single attributes on RHS. Okay, so you can see this step is done. So this I can say this is your step number 1 done. Okay, step number 1 that is done. So we already have single attribute on RHS. So this step is done. Now you check one by one. Okay, you tell me this FD, is this redundant? Is this FD redundant? This FD, is it redundant? Is it redundant? This FD, is this redundant? Tell me. So what you will do? If you want to check this FD is redundant or not, what you will do? You will find AC plus. In entire F1, can I say? Where you will find AC plus? Tell me. You want to check this is redundant or not? This FD is redundant or not? This FD is unnecessary or not? Then what you will do? You will find AC plus here. Yes or no? Here you will find AC plus. Agree with me? Here you find AC plus. So tell me what is AC plus here? AC plus will be AC. AC plus will be AC. That's it. That's it. So can I say this is not redundant? Yes or no? So can I say this is not redundant? Agree with me? Agree with me? Okay, so I can say, so you can see that AC does not determine C. So AC does not determine C. Okay, here in this AC does not determine C. So I can say this FD is not redundant. Okay, is this clear? Very simple, right? Yes or no? Now you tell me about the next one. What about this next one? This CD determining B. What about this next one? CD determining B. This we want to check. If you want to check this, then what you will do? Remember, you want to check this one. Is this redundant or not? Is it redundant? This FD, is this redundant? Then what you will do? In the remaining, okay, first you remove this, then just forget about this. Okay, for a moment you forget about it. For a moment, just forget about this. Is this clear? Just forget about this. Forget about this. Forget about this. Okay, now what you do? Now, in this remaining, what you do? You find, what you will find? You will find CD plus. Yes or no? You will find CD plus. This is what you will find. So tell me, what is CD plus? CD plus will be CD. D can determine EG. D can determine EG. Okay, yes or no? CD plus, that will be CD EG. CG can determine D also, that we already have. CE can determine A also. CE can determine A also. So what we got? CD EGA. CD EGA. CG can determine B also. CG can determine B also. So you got this. So you got A, B, C, D, EG. Okay, yes or no? So can you notice? CD that already determines B. Without this, agree with me? Without this, if you remove this, still you can see CD determines B. So remember, CD determines B. Okay, without this FD, right? Yes or no? Without this FD. So what I can say? So please tell me what I can say. So tell me what I can say. So this FD was actually redundant. Yes or no? So this FD was actually redundant. So this is what I can say. This is actually redundant. Yes. So we can remove it. Is this clear? So this FD is actually redundant. So we can remove. So we can remove it. Remember, this is redundant. So you can remove it. Okay. So in the next question I will ask. Before that, I will remove it because we already know you can remove it. So just remove it. Okay. Just remove it because we can remove it. Okay. So let me remove it. Now you tell me. Is this redundant? Is this redundant? First of all, you tell me, will you check this again? Again, will you check this? Again, will you check this? No, there is no need. There is no need. Okay, because remember, this is already equivalent to the previous one. They are actually equivalent because this is redundant. Please understand. This is redundant. This is redundant. So you can remove it. So you can remove it. Okay. So you don't have to check this again. Now let's directly check this. Is this redundant? Tell me. I am asking, is it redundant? Is it redundant? This is the question. So tell me, is this redundant? So what you will do? First you tell me what is the method you will apply. So first you will remove this. First you remove this. Now you check. Now you check. Now what you do? Now you find. What you will find? You will find BC plus. Okay, now you will find BC plus. So tell me what will be BC plus? If I find what is BC plus, so that will be BC. That will be BC, then that's it. That's it. Yes or no? So can I say BC does not determine D? Yes or no? So I can say now BC does not determine B, does not determine D. Okay. Is this clear? So this FD is not redundant. This FD, this is not redundant. Is this clear? Please tell me. Understood? Okay. So this is not redundant. So you cannot remove it. Okay. This you cannot remove. What about the next one? What about this one? Please tell me. What about this one? Let me know. I want to ask, is it redundant? Please tell me. Is this redundant? This FD, is this redundant? Let me know. I want to check this FD is redundant or not. So what you will do? First you will remove this, right? Okay, first you will remove this. Now, after removing this, you will find what you will find. After removing this, you will find what is CG plus, right? Yes or no? You will find what is CG plus. So tell me, what is CG plus? If you find CG plus, what that will be? That will be CG. That will be CGD. Okay, CG can determine D. D can determine E. D can determine E. Now you got CGDE. 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 So you got A also. You got A also. Now you have AC. Okay, so basically, can I get B? I cannot get B, right? Okay, yes or no? So that's it. So here, this is what you will get. So can you notice? CG does not determine B. This B we did not get. Okay, CG does not determine B. We did not get this B. Yes or no? So what I can say, this is also not redundant. Is this redundant? The answer is no. This is also not redundant. Okay, is this clear? So if you remove this, then you cannot determine B. Then CG cannot determine B. If you remove this, then CG cannot determine B. Okay. So anyway, so did you understand the concept? Please tell me. Please tell me, did you understand the concept? How to check if a FD is redundant or not? So we have seen how to find extraneous attribute on the LHS. We have also seen how to check if a FD is redundant or not. Now what is our task? Now our task is to find the minimal cover. Okay. Now we will find the minimal cover. This minimal cover we are going to find. Let me tell you the algorithm. The algorithm is so simple. What we will do, if you want to find minimal cover, then what we will do? First, we will simplify the RHS. Means on the RHS, you have single attribute. Okay. First, we will make sure that on the RHS, you have single attribute. Then what we will do? Then we will remove the extraneous attribute from the LHS. Okay. What we will do? We will remove the extraneous attributes from the LHS. From the LHS, we will remove all the extraneous attributes. Then we will remove all the redundant FDs. So that's it. So remember what we will do. Please understand. If you want to find minimal cover, finding minimal cover, how to find minimal cover? Finding minimal cover of FD set F. Okay, you have FD set F. Then how to find the minimal cover? So what we have to do? Let me know. So first you make sure that on the RHS you have single attribute. Okay, make single attribute on RHS. Okay, make single attribute on RHS. On RHS of every FD. Okay, this we do only for simplicity. It will make our task very simple. Okay, so just make this. This is only for simplicity. It will make our task very simple. Without confusion, you can do it. Okay, so remember, make single attribute on RHS of every FD. This is the first thing. Okay, this is the first thing. Now there are two things we have to do. Yes or no? Now there are two things we have to do. One thing is remove extraneous attribute on LHS. Yes or no? What we need to do? Extraneous attribute on LHS, right? Attributes on LHS. On LHS, this is what we need to do. And what the second thing we have to do? What are the second thing we have to do? We have to remove redundant FDs. Redundant FDs. Now tell me, these two things can we do in any order? Okay, I'm asking, is this order necessary? Is this order necessary? Is this a necessary order? Like first you remove the extraneous attribute, then you remove the redundant FD. Is this order necessary? No, this order is not necessary. So remember, these two things you have to do, can do in any order. Can do in any order, any mixing. In any order. Okay, remember, order does not matter. Is this clear? Okay, you can do in any order. These two things you have to do. The point is simple. These two things you have to do. Okay, you have to remove extra attribute on the LHS. Extraneous attribute on the LHS you have to remove. Also, you have to remove redundant FD. These two things you can do in any order. Is this clear? Please tell me, is this clear? Let me know. Let me know. You can do this in any order. So remember here also. Okay, this 2,3 can be done in any order. Okay, this is a note. This is a note. Step 2,3 can be done in any order. Can be done in any order. Can be done in any order. Okay, is this clear? In any order. Can be done in any order. So you can mix also. If you want, you can mix also. Okay, means for 1 minute you do this, for next 1 minute you do this, for next 1 minute you do this, for next 1 minute you do this. So you can mix also. Is this clear? Can mix also. Please tell me, did you understand? Let me know. So remember, these two things can be done in any order. You can mix also. Okay, can be done in any order. In any order, any mixing, you can mix also. Okay, is this clear? Can be done in any order, can mix also. But what is our ultimate target? Tell me, so when to stop? Okay, you can mix also. If you want, you can mix also. Then when to stop? When will you stop? This is my question, right? So when you will stop? Stop when nothing redundant. Okay, stop when we can't delete any attribute and any FD. Okay, stop when we can't delete any attribute and any FD. Is this clear? Any attribute and any FD or any FD. Is this clear? Let me know. Please tell me. Okay, means. What this means? You can't delete anything. We can't delete anything. What this means? We can't delete any attribute or any FD. This means you already got your irreducible set, right? Yes or no? It means you got irreducible set of FDs. Okay, and that is same as your minimal cover. And that is same as your minimal cover. That is same as your canonical cover. Please tell me, is this clear? Did you understand when to stop? Did you understand when to stop? Okay, so you will stop when to stop. You will stop when you cannot delete any attribute, any FD. Okay, we can't delete any more attribute, any more FD. Is this clear? Then it simply means you got your minimal cover. Let me know, understood? Please tell me, let me know, understood. Now you tell me, I told you that you can mix also. These two things you can do in any order. First you can do this, then you can do this. Or first you can do this, then you can do this. Or you can mix also. For 1 minute you do this, for 1 minute you do this, for 1 minute you do this, then for 1 minute you do this. You can mix also. Tell me, will you do like this? Will you do randomly like this? Will you do randomly like this? Which order will save you time? Of course you can do in any order. You can do in any order, but which order will save you time? This order will save you time. Is this clear? If you do in this order will save you time. This order saves time. Okay, is this clear? This order saves time generally, in general. Okay, this order will save time in general. In general, this order will save time. Is this understood? Please tell me. But of course, you can do in any order. Remember, can be done in any order. Okay, but this order generally saves time. In general, this will save time. Is this understood? Let me know. Did you understand my point? Okay, see, this is a misconception. Many students, what they think? They think first we have to do this, then we have to do this. No, you can do in any order, any mixing. Whatever you want, you can do. Okay, is this clear? So you can do these things, you can remove these things. You can remove extraneous attribute on LHS, you can remove redundant FD, you can remove these things in any order. Okay, but this order, if you first you do this, then you do this. If you do like this, then this order will save you time. Okay, so in the GATE exam, you can think about this order. So first you remove extraneous attribute from the LHS, then you remove redundant FD. Okay. So let's move on now. I hope you understood. Okay, so let's see some questions. Now we only have to do practice. That's it. We only have to do practice, nothing else. Let's see this question. Find the minimal cover. What we have to do? We have to find the minimal cover. Canonical cover or minimal cover, both are same things. So we have to find the minimal cover. Now tell me. So what is your step number 1? Tell me, what is your step number 1? In this question, you want to solve this question. So what is the step number 1? So first you make sure that on RHS you have single attribute. Okay, on RHS you have single attribute. But if you notice one thing, for extraneous attribute, you don't need single attribute on RHS, right? Yes or no? Okay, to check extraneous attribute, please understand, to check extraneous attribute on LHS, to check extraneous attribute on LHS, we don't need single attribute on RHS. Okay, that requirement we don't have. We don't need single attribute on RHS. When do we need single attribute on RHS? Please tell me. Let me know. When do we need single attribute on RHS? This single attribute on RHS is required when you remove redundant FD. Okay. Single attribute on RHS, that is required when removing redundant FD. When you remove redundant FDs. Okay. So when you are removing this, then we need single attribute on RHS. Then we keep single attribute on RHS. Attribute on RHS. Okay, is this clear? Okay, so anyway, so you tell me on the LHS, do we have extraneous attribute? First you check extraneous attribute on LHS. Tell me, first you check extraneous attribute on LHS. This is your step number 1. Okay, so tell me, first you check extraneous attribute on LHS. Is there any extraneous attribute on LHS? Check extraneous attributes on LHS. Attributes on LHS. Okay, so this is what you do. First you check extraneous attribute on LHS. So can you notice here nothing to check? Yes or no? Agree with me? Because only single attribute on LHS. Only single attribute on LHS. There is nothing to check. Again, there is nothing to check. Okay, so where we have to check? Where we have to check? We have to check here. Okay, so you just find what is W plus. What is W plus? Just find what is W plus is W. Find what is Z plus is Z. So can I say that we don't have any extraneous attribute on LHS, right? Yes or no? See, notice. This Z is not extra because W cannot determine XY. This Z is not extra because this W cannot determine XY. This W is not extra because Z cannot determine XY. You can easily see. Okay, so no extraneous attribute on LHS. Is this clear? So no extra attribute on LHS. Attribute on LHS. Okay, so this step is done. Okay, this LHS is done. Now what we have to do? Now your step number 2. For that, what you need? You just make sure on RHS you have single attribute. Okay, for step number 2, what you do on RHS, you put single attribute. Okay, so just put a single attribute on RHS. Y determining W, Y determining X, Y determining Z. Okay, so this is what you got. Now what you will do in this step, remove redundant FDs. Okay, remove redundant FDs. Okay, remove redundant FDs. So simple. Now let's check which FDs are redundant. Let's check, and can we remove them? One by one you tell me. Okay, first just quickly see this and tell me which FD looks like redundant. Just quickly see. For example, what about this one? Is this redundant? Is this redundant? Okay, one by one I am asking. Some question I am asking, you tell me. Is it redundant? Tell me. Okay, so is this redundant? If you want to check this is redundant or not, so what you will do? In this you will find X plus. In this you will find X plus. So tell me, what is X plus? What is X plus in this? In this, what is X plus? That is X only. So can I say this is not redundant? Yes or no? So this is not redundant. Okay. Now, what about the next one? What about this? WZ determining X. Please tell me about this one. What about this? Is this redundant? Is it redundant? This FD, is this redundant? In the remaining, you find WZ plus in remaining. Okay, so in remaining FDs. Okay, in the remaining FDs, what is WZ plus? Tell me. What is WZ plus? In the remaining FDs, for a moment, assume this is gone. Okay, don't consider this. Don't consider this. In the remaining, you find. In remaining FDs, remember. Okay, in the remaining FDs, you find. So what is WZ plus? WZ plus, that will be WZ. WZ can determine Y. Y can determine WXZ. Y can determine WXZ. Yes or no? So can I say yes? So can you notice that WZ determines X in remaining FDs? In remaining FDs. Okay, is this clear? In remaining FDs. So what that means? Let me know what that means. So that means this is a redundant. Yes or no? Is this redundant? The answer is yes. Okay. So this is redundant. So you can remove this. Okay. So in the next step, this is gone. Okay. So just forget about it. This is gone. Now you tell me about this one. Is this redundant? Now tell me about this one. Is it redundant? Is it redundant? Tell me. Check about this one. Is this redundant? The answer is no. Why? Why the answer is no? Because in the remaining you find, in remaining FDs you find what is WZ plus. Okay, in the remaining FDs. Okay, just find what is WZ plus. What is WZ plus in the remaining FDs? That will be WZ. That's it. Yes or no? So in the remaining FDs, I can say that in the remaining FDs, I can say WZ does not determine Y. So this FD is not redundant. What about the next one? What about the next one? Tell me. What about this one? Is this redundant? Is this redundant? Tell me. This FD, is this redundant? The answer is yes. Why? What is the answer? The answer is yes. Why? Because in remaining FDs, okay, in remaining FDs, you check. In remaining FDs, assume this is gone. Assume this is gone. In remaining FDs, you find what is Y plus. So Y plus will be, you can see Y plus will be YXZ and X will determine W. So that's it. So can you notice in the remaining FDs, Y can determine W. Okay, so this is redundant. So this is also gone. Yes or no? So this is also gone. Okay, now you quickly tell me. Now you can notice there is no other redundant FD. Can you check? Is this redundant? Is this redundant? In the remaining, find Y plus. In the remaining, in the remaining, you find Y plus. In the remaining, find Y plus. What that will be? In the remaining, what is Y plus? In the remaining, Y plus does not contain X. In the remaining, in these three, Y plus will be YZ. That's it. Okay, so this is not redundant. What about this one? What about this one? In these three, what is Y plus? In these three, Y plus will be, that will be YXW, YXW, right? Yes or no? So this is also not redundant. So I can say, for this is your final answer. Okay, this is your final minimal cover. This is your final minimal cover. Please tell me, is this understood? Did you understand? Let me know. So this is your final minimal cover. Let me know, did you understand? Please tell me. How to find minimal cover, did you understand? Okay, so quite simple. Now let's see this question. This question is from Korth. I've taken this question from Korth. Let's solve this. Can you take your copy pen? Just 2-3 examples we need to do. This chapter is very simple. We need to do some practice. That's it. Okay, so this question is taken from Korth. Now, can you take your copy pen? Let's solve this. In this question, I will tell you that minimal cover is not unique. This canonical cover, this may not be unique. This point we have to see. Okay, so in this example, it will be clear. So tell me, here, this set of functional dependency is given to you. A determining BC, B determining AC, C determining AB. Okay, so remember, this is the set of functional dependencies that is given. A determining BC, B determining AC, C determining AB. Okay, this is a set of functional dependencies that is given to you. Is this clear? Now let's see. Now let's apply our algorithm. Okay, let's quickly do. First you tell me. Let's quickly do. First you tell me, on the LHS, is there anything to check? Is there anything to check on the LHS? There is nothing to check on LHS, right? Yes or no? Can I say nothing to check on LHS? There is nothing to check on LHS. Okay, so there is nothing to check on LHS. All we have to do, what we have to do? We just have to check the RHS. Okay, we have to, what we need to do? Tell me. Only check redundant FDs. Correct? Only check redundant FDs. That is all you need. Okay, only check redundant FDs. This is the only thing you have to do. Nothing else. Okay, nothing else. Right? Correct? So, what you do? First, you will make sure that on the RHS, you have single attribute. Okay, first, let me make sure that on RHS, you have single attribute. Okay, so this is what I'm doing. A determining C, B determine A, B determine C, C determine A, C determine B. Okay, so these are the FDs that you have. Now, let's see. One by one, you tell me. First, you tell me, what about this one? Is this FD redundant? Is this redundant? Let me know. Is this redundant? Please tell me, yes or no. Is this redundant? In the remaining, you find what is A plus. In the remaining, what is A plus? Tell me. In the remaining, you find A plus. What that will be? If you find in the remaining, if you find A plus, here you find A plus. Here you find What is A plus? A plus will be AC. Okay, A plus will be AC and C can determine B. So yes, this will be redundant. Okay, so you can easily see that A can determine B. A can determine B. Okay, so I can simply say that yes, this is redundant. So we can remove it, right? Yes or no? Okay, so we can remove it. So in the next, what I will do, I will just remove this. Now this is gone. Okay, now this is gone. What about this one? A determining C. Is this redundant? This is not redundant. You can check. Okay, this is not redundant. What about B determining A? What about this B determining A? Tell me. What about this B determining A? Is this redundant? In the remaining, you find what is B plus. In the remaining, you find what is B plus. In the remaining, B plus will be B, C, A. Yes or no? So I can say this is also redundant. Okay, this is also redundant, right? This is also redundant. Is this clear? This one is also redundant because the reason, let me tell you the reason. Because in remaining FDs, if you find what is B plus, that will be B. B can determine C. C can determine A. Okay, so you can see in the remaining FDs, I can say that B is determining A. Okay, so this is also redundant. So this is also gone, right? Okay, so can I say that this is also gone? Okay, now these two things are gone. Now you tell me, is there anything else redundant? Now, is there anything else that is redundant? Is this redundant? Is this redundant? No. Is this redundant? No. So what did we get? What did we get? We get a minimal cover, right? Yes or no? Is this clear? We got minimal cover. Okay, this is your minimal cover first. This is your first minimal cover. Let's call it FM1. Is this clear? This is your minimal cover 1. Let's call it FM1. Please tell me. So remember, this is your first minimal cover. This is one of the minimal covers. Okay, this is one of the minimal covers. This is one of the minimal covers. There can be more. Can you notice? First of all, you tell me, is this minimal cover? Do you agree with me that this is minimal cover? Do you agree with me that this is minimal cover because you cannot remove any attribute, you cannot remove any FD? Is this clear? Please tell me. Why this is minimal cover? If anyone asks you, why this is minimal cover? See, this is what we got. This you can remove. Okay, this is what we got, right? This is your minimal cover F1. This is your minimal cover F minimal 1. Why this is minimal? Tell me what the reason this is minimal. This is minimal cover because you cannot remove any attribute or any FD. This is minimal cover because it is irreducible. It is irreducible. Yes or no? It is irreducible set of FDs. Okay, we cannot remove any attribute, any FD. We cannot remove any attribute or FD. Any attribute or FD. Is this clear? Please tell me, understood? We cannot remove any attribute or FD. So this is your minimal cover 1. Now you tell me, can you change the order and can you get some other minimal cover? Let's try to get some other minimal cover. Okay, what I will do? I will try to get some other minimal cover. For example, let me start with this A determining C. Let me start with this. I can start with this, right? Is there any fixed order that I have to go in this order? Please tell me. Is there any fixed order that, okay, I have to go in this order, I have to check in this order? No. This is set of FDs. Yes or no? This is set. Okay, this is set of FDs. There is no order here. There is no order here. So what I can do, I can start by this. You can see that this will be redundant. Okay, you can check. This will be redundant. Okay. After checking this, what I will do? After checking this, you can check this is also redundant. Can you check? Can you check? Please tell me. See what I am saying. I am saying first you check that this is redundant. Okay. So now we are finding another minimal cover. See our task. What is that? Okay, let's find another minimal cover. Our task, let me tell you, our task is find another minimal cover. Find another. Another minimal cover. Give me another minimal cover. Find another minimal cover. Okay. Is this clear? Let's find minimal cover number 2. So you can see this is redundant. Okay. Because this is redundant, so this you can delete, right? Yes or no? So I can delete this. So what I can do? This is gone. This is gone. Now you tell me, can I say that this is also redundant? Please check. Please check. Is this redundant or not? Just check this. Is this redundant? Let me know. Is this redundant? Is this redundant? In the remaining, you find what is B plus. Okay, in the remaining, you find what is B plus. Find B plus. So what B plus will be? That will be B. B can determine C. C can determine A. Okay, so you can see in the remaining, B can determine A. So can I say that? Yes, this is redundant. So because this is redundant, so this is also gone, right? Okay, so I can say this is also gone. So I can delete this also. Is there anything else redundant? Is there anything else redundant? In this, which one is redundant? Something is redundant. What is redundant? Tell me. For example, this is redundant. Can you check this is redundant? Can you check? Can you check this is redundant? Okay, you can check. In the remaining, what is C plus? In the remaining, what is C plus? C plus is CAB. Okay, so this is also redundant. Agree with me? Okay, so you can, what you can do, you can remove this also. Now you tell me, did you get a minimal cover? Can I say this is a minimal cover? Yes, this is your another minimal cover. This is your another minimal cover. This is your another minimal cover, FM2. Let's call it FM2. Why this is minimal? Anyone? Anyone? Why this is minimal? Tell me. Why this is minimal? Why minimal? Minimal because you cannot reduce. Minimal because it is irreducible. Because it is irreducible. You cannot reduce it, right? It is irreducible. Please tell me, is this clear? Let me know. This is irreducible, right? So this is your minimal cover number 2. Okay, now you tell me one thing. This is also minimal cover. How many FDs are here? In this minimal cover, how many FDs? In this minimal cover, how many FDs? 3 FDs. 3 FDs. In the previous minimal cover, how many FDs? In the previous minimal cover, how many FDs? In the previous minimal cover, 4 FDs. So tell me, this question, does it make sense? I am asking you this question. How many FDs in minimal cover? Does it make sense? How many FDs in minimal cover? In minimal cover? In minimal cover? Does this question make sense? Does this question make sense? This is nonsense question. Okay, this is nonsense question. Is this clear? This question is nonsense question, and let me tell you where this question will be asked. In which exam they will ask you this question? In the Hulu Hulu test series. Okay, so remember, this is nonsense question, and they will ask you this question in some test series. Definitely you will find this question in some test series. Okay, so this is a nonsense question in Hulu Hulu test series. This is for Hulu Hulu test series. So anyway, did you understand what I'm trying to say? How many FDs in the minimal cover? That can vary. Yes or no? That is not same. That is not same. Minimal does not mean minimum. Please understand. Please understand. Minimal does not mean minimum. Minimal cover. Minimal cover is not minimum. Is not minimum cover. Is not minimum. Okay, is this clear? Please tell me. Minimal cover, what that actually means? What the correct word for minimal cover? Like which word is better word for minimal cover? That is irreducible set. This word is actually very good word. Irreducible set of FDs. Okay, this word, this is the better word I can say. Irreducible set of FDs. So remember, minimal, that simply means irreducible. Minimal means irreducible. Is this clear? Did you understand this? Please tell me. So you can have many minimal cover, and different minimal covers can have different number of FDs. Okay. So remember, we can have many minimal covers. We can have multiple minimal covers. multiple minimal covers. Okay. So remember, we can have multiple minimal covers, and different minimal covers can have different number of FDs. Different minimal covers can have different number of FDs. Different number of FDs. Okay. So is this clear? Simple point. Now, let me tell you something more interesting, that so we got this minimal cover number 2. Can you give me another minimal cover? Can you give me another minimal cover? Tell me. Now let's find another minimal cover. Okay. So what you do? Find another minimal cover. Can you give me that? Find another minimal cover. So far we have found 2 minimal covers. Now can you find another minimal covers? Any idea? Any idea, anyone? I want to find another minimal cover. Another minimal cover I want to find. Okay, so tell me, is there any idea? Yes, I can do in some other different order. For example, what I can do, I can remove this. Okay, let me start by removing this. This is redundant. Agree? This is redundant. Okay, so let me start by removing this. So first what I will do, first I will remove this. Then what I can do, is this redundant or not? B determining C. Is this redundant or not? Tell me. Now you check, is this redundant or not? I am asking, is this redundant? Please tell me. Is this redundant? Please tell me. Yes or no? Is this redundant? What is the answer? This FD, is this redundant? Yes, this FD is redundant, right? Why this FD is redundant? What is the reason? Because in the remaining, okay, in these and in these, okay, you find what is B plus. What that will be? B plus will be B can determine A. Okay. So, okay, this is not redundant, right? Okay, okay. This is not redundant because in the remaining, okay, this is actually not redundant. Okay, 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 okay. This is actually not redundant. No, this is not redundant. Okay, this is not redundant because you can see that in the remaining, the B cannot determine C. B cannot determine C. So this is not redundant. Okay, no problem. So first what we have done now in this, can you notice that? Okay, in this you tell me, is this redundant? C determining A. Is this redundant? What about this one? You tell me about this one. Is this redundant? Is this redundant? Tell me about this one. This one. Is this redundant? What is your answer? The answer is yes. This is redundant, right? Because in the remaining, what is C plus? Okay, in the remaining, you find what is C plus in the remaining. C plus, what is that? That will be C, B. B can determine A. Okay, yes or no? So this is redundant. So I can delete this. So I can delete this. This is also gone. Now, is there anything redundant? Now, is this redundant? No. Is this redundant? No. Is this redundant? No. So can you notice we got another minimal cover? We got another minimal cover. This is your minimal cover FM3. Is this clear? We got another minimal cover. So you can have many minimal covers, right? Okay, this is the point I want to tell you, that you can have many minimal cover. Again, this is irreducible. You cannot reduce further. Again, this is irreducible set of FDs. Okay, is this clear? So the point is simple, that you can have many minimal covers. In the exam, they will not ask you how many minimal covers are there. They will not ask you, don't worry. Okay, they are not going to ask you. Okay, is this clear? But they can ask you MSQ question. Is this clear? They can ask you MSQ question. So actually, if you try this question, let me tell you, if you try this question, at least 4 minimal covers you can get. 3 minimal cover I have given to you. Yes or no? For this question, if you solve this question, we have already seen that this question has at least 3 minimal covers, right? Yes or no? I have given you at least 3 minimal covers. But actually, if you check it, you can get at least 4. At least 4 minimal covers you can get. Okay. So you can see different minimal covers. They have different number of FDs. this minimal cover you can get this minimal cover, you can get this minimal cover, you can get this minimal cover. So you can get different minimal covers. Is this clear? Please tell me. Okay, so you can easily see, this is the point, this is the complete point, that minimal cover might not be unique. Okay, you can get different minimal covers. Okay, for the same question, I have already given you 3 minimal cover. Okay, and you can find the remaining, you can find at least 4 minimal cover are there, at least 4. There can be more also. Okay, is this clear? Maybe there are 5, maybe there are 6, maybe there are 7. There can be more, there can be. Okay, but don't worry about it. In the exam, they will not ask you how many minimal cover are there. Okay, they will not ask you, but I'm telling you that there can be more than one minimal cover. Basically, minimal cover is not unique. This point is important, that minimal cover is not unique. And the second point that is important, what is that? That different minimal covers can have different FDs. See, here you have 3 FDs. Here you have, for example, here actually you have 4 FDs. Yes or no? If you notice, here you have 4 FDs. For example, if you break it, you can have 4 FDs. Is this clear? Please tell me. Or I can say like this. For example, here 6 attributes are there. Here you can have 6 attributes. Here you have 7 attributes. Okay, is this clear? If you break this RHS, then you can get 4 FDs. So anyway, I hope you understood the point. Please tell me, did you understand? So this is what I'm saying, that first of all, minimal cover is not unique. That is the first point. You can get many minimal covers. Okay, is this clear? The second point, this question is nonsense if I ask you how many FDs are there in a minimal cover. In minimal cover, how many FDs are there? That question is nonsense. Okay, is this clear? Everything that I told you, is that clear? So can you see this question? Does this question make sense? The number of functional dependencies in minimal cover of F. This question, does it make sense? This F is given to you. This F is given to you. Does this question make sense? This is a nonsense question, right? Yes or no? You can see this is a nonsense question. Okay, so you can put it here. Jethalal. Okay, so this is a nonsense question. The number of FDs in minimal cover. This is a nonsense question. But can you notice something beautiful? So many students, they waste time on this type of questions. Okay, this is from a test series. Let me tell you. Okay, I will not tell you the name, but this is from a very popular test series. Okay, so you can see so many. This is your, I can say, Hululu test series question. Okay, so you can see so many students waste time. Yes or no? So many students, they waste time. Okay, they will solve it. What student will do? Let me tell you. Students will solve this question. Some student will get answer 3, someone will get 4, someone will get 5, and then they will fight. They will fight with each other. Is this clear? They will comment that answer will be 3. Someone will say answer will be 4. Yes or no? Then they will fight with each other. Then they will reply. Basically, then they will ask in the Telegram group. Basically, they will waste a lot of time. Because of this, I can say because of this poor question. This question is poorly framed. This question is nonsense. But because of this nonsense question, if you find this question in the test series, then you will be thinking, sir, what should be the answer? In the GATE exam, if this question comes, then what answer should I put? So these type of things are nonsense. This is what I'm telling you. Don't waste your time. The GATE exam is created by professors. Yes or no? The GATE exam, that is created by professors, IIT, ISC professors. They know everything. Okay, those professors, they are not coaching, I can say, coaching test series makers. Is this clear? They are knowledgeable people. They have done PhD, postdoc. Okay, they have done research in these areas. So they know everything. So they will properly frame a question. Okay, their question will not have this type of mistake. So anyway, don't waste time. I'm telling you that a lot of students, they waste time on this type of nonsense questions. Okay, is this clear? You can see this is given in the Navate. This thing is already given in the Navate. This is your Navate book. Okay, so in the Navate, actually, this thing is given that minimal does not mean that you have number of FDs is minimum. Okay, so you can see if several set of FDs, they qualify for minimal covers. Okay, if several minimal covers you have, then remember then additional criteria you have to define. Yes or no? Is this clear? Is there anyone here who is thinking, sir, in the question, if they ask which minimal cover will have minimum number of FDs, that question makes sense. Yes or no? Which minimal cover, okay, this, let's assume this condition is given to you. Okay, in the exam, in the gate question, this condition is given to you that on the RHS you have single attribute, and which minimal cover will have minimum number of FDs. Okay, this type of additional criteria will be given. So don't worry about it. I'm telling you that if they ask you this question, this nonsense question, if they ask you in the gate exam, okay, this question, if they ask you in the gate exam, then they will give you some additional criteria. They will give you a simple question, first of all. Okay, a simple question they will give you, and then they will define criteria, additional criteria they will define. Is this clear? Please tell me. So if there are several FDs, if there are several minimal covers, if you have more than one minimal cover, then additional criteria can be defined. Okay, additional criteria can be defined. For example, you can choose the additional criteria like smallest number of FDs, or you can choose the smallest criteria like minimum number of attributes. Is this clear? So these are some additional criteria you can choose. Please tell me, did you understand the point? Let me know. So the point, see, this Navate, in this Navate, it is given that if you have more than one minimal covers, okay, if you have more than one minimal covers, then additional criteria must be given. If, okay, additional criteria can be defined. Okay, can be, or I can say must be defined. Then additional criteria must be defined and given. It should be given in the question. Is this clear? Additional criteria must be defined and it should be given in the question, this additional criteria. And what are the possible additional criteria? Tell me, which are some possible additional criteria? Like this additional criteria, what it can be? Please tell me. This additional criteria, what it can be? For example, this additional criteria can be like, I can say this additional criteria can be smallest number of FDs, because different minimal cover can have different number of FDs. I told you, different minimal covers, they can have different number of FDs. So you can define this additional criteria, or you can define this additional criteria like minimum number of attributes, minimum number of total attributes. Okay, minimum number of total attributes. So like this, I hope you understood. Okay, so these are some additional criteria that can be defined in the question. Okay, so in the question they will give you, I'm telling you this, in the GATE exam or in the goclasses test series. See, in the goclasses test series, if I give you this type of question, then what I will do, I will give you this additional criteria, right? Yes or no? This same question, if I give you in the goclasses test series, then this question will have at least 5 to 6 lines, because I will define everything. Okay, I will tell you what I'm asking. Is this clear? Everything I will define. This additional criteria I will define. I will also tell you that on the RHS you should put only one attribute. Is this clear? So everything I will give to you. Everything will be defined. So anyway, don't worry about it. Okay, just forget about it. Just don't worry about it. Okay. Now one more misconception, that is this question. Canonical cover, minimal cover, are they different or are they same? Canonical cover, minimal cover, are they different or are they same? You can see so many views. Almost you can see 5,700 views and so many comments, 9 comments at least. 9 comments. Are they same or are they different? So they are same. Okay, they are same. Canonical cover, minimal cover, they are same. This is given in the Navate book. So this is another nonsense question. Okay, actually, see what is happening. Let me tell you. See, Navate and Korth, if you study 2 books, then in the Navate, it is already given that minimal cover, canonical cover, they are same. Okay, you can see, this is your Navate book. The source is Navate. In the Navate book, if you study, everything is already given that basically minimal cover, that is same as your canonical cover. Everything is basically same. Okay, you can call it minimal cover, you can call it canonical cover, everything is same. Now let me tell you something. See, the difference between Korth and Navate, these two books, let me tell you this small difference. So the difference is something like this. Let's assume that, okay, I'm telling you this difference. So let's assume that you have this, you get this minimal cover. Okay, you are solving a question, and let's assume this minimal cover you got, that A determining B, A determining C. Okay, this minimal cover you got. Is this clear? Let's assume this is the minimal cover you got. You got this minimal cover. Okay, this minimal cover you got. Okay, you got this minimal cover. Clear? Now, once you get this minimal cover, you got this minimal cover. Now, once you get this, then what Korth says, what this book Korth says, and what this book Navate says. Let me tell you. This Korth book says that if LHS is same, then merge them. Okay, this Korth book, what this Korth book says? This Korth book says that if LHS is same, just merge them. Is this clear? Okay, in this Korth, this is called canonical cover. Is this clear? Please tell me. In the Korth book, this is called canonical cover. Means if LHS is same, then mix them. Okay, so in the Korth book, if you study this Korth book, then after mixing, we are calling it canonical cover. You tell me one thing, just use your common sense. These two things are same, right? Yes or no? Yes or no? These two things are same, because you can combine the RHS. This thing, they are basically same. You can split the RHS, you can combine the RHS. Okay, so in the Korth book, they are saying this condition is given, that if the LHS is same, you mix them. In the Navate, they are saying that this, okay, in the Navate, they say that on RHS, you put only one attribute. Okay, so on RHS, you put only one attribute. See the difference. Okay, in the minimal cover, in this minimal cover, I'm telling you the difference between two books. Okay, in the Korth book, what they do, and in the Navate book, what they do. Let me tell you the difference. The Korth says that if LHS same, then mix them. Okay, if LHS same, if LHS of 2FD same, then merge them. Okay, then combine them. Is this clear? Very simple. And what this Navate says? This Navate says that keep one attribute on RHS. Okay, keep one attribute on RHS. Keep one means don't mix. Keep one attribute on RHS of every FD. Okay, is this clear? So once you get this minimal cover, let's assume once you get this minimal cover, then this is Korth and Navate. This is what they say. Once we get minimal cover, okay, once you have gotten minimal cover, then after that, this is what Korth and Navate says. Is this clear? Please tell me, did you understand? Please tell me, did you understand? Korth says that if LHS of 2FD is same, then just combine them. And Navate says keep single attribute on RHS. So let's assume this is the answer you get. Okay, let's assume this is the answer you get. For example, this answer you got, let's assume. Then what Korth says? Korth says that if LHS is same, combine them. Means this is what Korth says. And Navate says that on RHS you put single attribute. But the point is, let me tell you. In Navate, this is called Navate, this is called minimal cover also, and this is called canonical cover also. Navate is very, I can say, very good book. Okay, what this Navate says, this calls it minimal cover also. He calls it canonical cover also. He also says, Navate also says that if you combine, then also no problem. Okay, see, Navate is so flexible. Yes or no? Navate also says that if you combine, then also no problem. This is also fine. Please tell me, did you understand? Navate says that you can combine also, no problem. It is given. See, this is given. Look at this. If you combine, then also no problem. Notice. If you combine FDs with same LHS, This is given in the footnote. Yes or no? This is given in the footnote. Some students, they don't read the footnote. This is given in the footnote. Okay, this is the footnote of the page. In the footnote, it is given that combine the FDs with same LHS into a single FD. Okay, then also you will get minimal cover. See. This resulting set is also a minimal cover. Read this line. The resulting set is still a minimal cover. Okay, the resulting set is still a minimal cover. Read this. Okay, so if you combine, if LHS is same, and you combine, this is also minimal cover, this is also minimal cover. So this is the final conclusion I want to give you. Let me give you the final conclusion. Let me tell you the final conclusion. This is the conclusion. See, before I tell you the conclusion, you tell me why I am telling you all these things, that Nawate has given this, Korth has given this. Okay, why I am telling you all these things? Because I don't want you to waste your time in this type of poor questions. Okay, on the Telegram group, someone will ask you, is canonical cover, minimal cover same? Then you will say, yes, they are same. Okay, then they will say, no, they are not same. Okay, in Korth book, it is given that they are not same. Okay, in that coaching institute, this is given that it is not same. Yes or no? So this type of silly things, you will waste your time. So that is the reason I'm telling you all these things, so that you don't waste your time. Is this clear? So let me give you the final conclusion. What that? The final conclusion is that, this is the conclusion that, assume your final cover is this. Assume you got minimal cover equal to, see, assume you got minimal cover this. Okay, when you are solving the question, assume you got this minimal cover. Now, this is the final conclusion, remember. Now, if you write it as it is, this is also minimal cover. And if you mix, this is also minimal cover. This also, both are minimal covers. Is this clear? Both minimal covers, both canonical covers. Both are minimal covers. Is this clear? Please tell me. So this is also minimal cover, this is also minimal cover. Is this understood? Let me know. Okay, so if you do this, both are minimal covers. This is the final conclusion. Okay, another conclusion, canonical cover, minimal cover, all these things are same. Canonical cover, same as minimal cover, same as irreducible set of FDs. Irreducible set of FDs. Okay, so these things, all these things are same. All these things are same. Please tell me, understood? Let me know. So don't waste your time on some nonsense questions. Okay, on some nonsense questions, don't waste your time. I told you everything. Okay, you can see I have told you everything. Every point I have already told you. You can see this is given in the Nawate. What is given? This is a screenshot from the Nawate. You can see canonical cover, minimal cover. Yes, they are same. Yes or no? Canonical cover, minimal cover, all these things, they are same. Okay. Anyway, let's move on now. So I hope you understood everything that I told you. So this is your chapter. Your chapter is over. Anyone has any doubt, you can ask. This is your chapter. So did you understand everything? Please tell me. In the exam, if they give you some set of FDs, can you find the minimal cover? If MSQ question is given to you, MCQ or MSQ question is given to you, remember, there can be more than one minimal cover. Minimal cover is not unique. Okay, so this is the point, that minimal cover is not unique. This is the point. Remember, minimal cover may not be unique, may or may not be unique. Minimal cover may not be unique. May not be unique. Okay, so in the MSQ question, you should take care. So take care in MSQ questions. Okay, is this clear? So take care. When you should take care in MSQ questions. In MSQ questions, you must take care. Okay, because minimal cover may not be unique. Okay, you can have many minimal covers, you can have, that may not be unique. Okay, so this is your important point. So everything we have seen. Are you confident? Please tell me. Are you confident? Also, I told you all those things, all those small points I told you where students will waste time. Okay, I have told you all those small points where many students they waste time. Did you notice this canonical cover versus minimal cover? Did you notice 5,000 views, 6,000 views on that question? Canonical cover versus minimal cover, 6,000 views, and many comments are there. Okay, students are fighting with each other. Is this clear? So that is the reason I told you everything. All the small points also I told you, so that you don't waste time. The final conclusion: minimal cover, canonical cover, irreducible set. These are same. All of them are same. Okay. So anyway, whatever we have seen, that is enough. Please tell me, understood? Let me know. Understood? Now let me give you one homework. This set is given to you. This set of FDs is given to you. You need to find minimal cover. Find the canonical cover. This set of FDs is given to you. Okay. So just try this. Just try this. Answer is already given here. Okay. You can have multiple. Remember, you can get multiple covers. You can get more than one minimal cover. Okay. Maybe you can get 3, 4, 5. I don't know. Okay. Yes or no? Maybe you can get 2, 3, 4, 5, 6. I don't know. I don't know. But the point is, you can get many minimal covers. Okay. At least 2 minimal covers you try to find. This is the homework. At least 2 minimal cover you try to find. Okay. And at least 2 minimal cover I have given to you. You can see this is one of the minimal cover. This is another minimal cover. So at least 2 minimal cover I have given to you. If you apply different order of removal, then you can get different minimal cover. Okay. Basically, if you change the order of removal, you are removing the extraneous attributes on the LHS. You are removing the FDs. Okay. You are removing redundant FDs. So if you change the order of these things, okay, if you mix them and if you change the order of these things, then you can get different minimal covers. Okay. So different order of considering extraneous attributes can result in different minimal covers. So this is your one question. You try this question, the answer is already given to you. You can also try this question, find the minimal cover, canonical cover. You can try this question also, and you can try this question also. You can try this question also. Answer is given to you. Okay, answer is already given to you. So that's it. So this is your chapter. Okay, thank you everyone. Anyone has any doubt? If anyone has any doubt, you can ask. And if you understood everything, please tell me. If anyone has any doubt, you can ask. And if you understood everything, please let me know. Shivam is asking, by keeping only y determining wxz gives everything, so that will be minimum cover. I'm not understanding your doubt, Shivam. In which question are you asking? I'm not understanding your doubt. So Shivam, can you ask in the private Telegram group? I will answer your doubt. Okay, because I'm not getting your doubt. So you can send the screenshot of the slide. Okay, you are asking some doubt in some slide. So please send the screenshot of the slide, and you can write your doubt in the private Telegram group. You can ask. Okay, and you can tag me. I will reply. Okay. Okay. Thank you, everyone. Thank you so much. Bye.